So the last quadrilateral that we're going to discuss is the kite. Okay, so this is the kite. Let's see what we know about the kite. If you just look at it, what do you think? What do you think's happening there? It kind of looks like these sides here and here are equal as well as these sides. So let's verify that. Let's do some measurements. So let's measure these two sides. We can see that they're both 9.05, and let's do the same thing over here. And we see that they're 18.08 centimeters. So yes, we have consecutive sides being congruent with a kite. Okay, what else do we see? Let's see. I have this angle that's formed right there. Let's measure that angle. That angle is 132.94, and let's do the same thing with this angle here. Again, 132.94. Now, so what that means is that we have one pair of opposite angles being congruent. Now, does that happen with the other one? So let's take a look. So that angle there is 63.56. Let's do something over here. 30.55. So it looks like with the interior angles, only one pair of interior angles, opposite interior angles, are congruent. And which pairs are they? That's the angle that's created by the non-congruent sides. So you'll notice that here our two non-congruent sides create this angle. That angle is equal to its opposite angle, which is also created by those non-congruent sides, right? There's our angle measure, there's our side lengths. Okay, so those are two very important properties with a kite. Now, let's take a look at its diagonals. Okay, so I'm going to move these out of the way. Let's construct some diagonals using the segment tool. And look at those diagonals. What's happening there? So let's just do some extra measurements. Let me put a point at their point of intersection, and let's measure that angle that's created by the intersection of the diagonals. So if we measure this angle, ooh, look at that, it's 90 degrees. And if this angle is 90 degrees all the way around, it's 90 degrees. So what can we say about its diagonals? They would be called perpendicular. Good. Okay, so let's take some notes. Okay, so the definition of a kite is that it's a quadrilateral that has two pairs of consecutive congruent sides. We know that the diagonals are perpendicular, and it contains one pair of opposite angles that are congruent. And the opposite angles that are congruent are the angles that are formed by the non-congruent consecutive sides. So we would mark our sketch like this. There's our consecutive congruent sides. Here are the angles that are going to be congruent, those opposite angles, and then, of course, those diagonals are perpendicular. The fact that those diagonals are perpendicular is going to be really important to us when we start looking at the lengths of the diagonals and finding areas and things like that, because you'll notice here that we have this right angle, which is also, here's a right angle, right? And we have our congruent sides there. And what else we know is that this diagonal also bisects these angles here. Okay, we didn't really look at that at the sketch pad, but it does. And it creates these congruent right triangles. Okay, these congruent right triangles here and here. So, and it also bisects the short diagonal. There's a lot about a kite that we didn't really investigate, but because I'm leaving it to the simple basics with the book. But here, the shorter diagonal, or the diagonal that connects the opposite angles, is also bisected by this diagonal. Anyway, what we end up having, which you should be concerned about, is that these two right angles here are congruent, and right triangles, and these two right triangles right here are congruent as well. Okay, so keep that in mind. So here's our first example applying our kite rules. Okay, so you know it's a kite because those two pairs of consecutive sides are congruent. And then because of that, we know that we have a pair of opposite congruent angles, right? So this angle here is 105, which would make this angle right up here 105. And my pen's not working, so sorry. Give me 1 second. Okay, so as we said, this angle here is 105. Now it is a quadrilateral, so we know that the sum of the interior angles of a quadrilateral is what? Should be 360, right? So the three angles that we have should add up to, that's 210, that's 260, so our missing angle here is 100 degrees. Not drawn to scale, that's okay. Okay? Let's look at one more example, but this time focusing on the segments. Okay, so it says find the side lengths of the kite and write the lengths in simplest radical form. So what we see here is that we have the lengths of the diagonals. And as you see, remember I said before, that diagonal that connects those opposite angles, the opposite congruent angles, is being bisected, which you could see happening here. We also know that those diagonals are perpendicular, so we could fill in our right angles, okay? Now that's going to be important because we're looking for the side lengths of the kite. And we know that if this side here, PQ, is X, we can say that PS is also X. They're the same, right? Because they are congruent. And we know that QR and SR are going to be congruent, so let's call that Y. Now, how are we going to go about finding our missing side lengths? We have a couple ways. You could use the Pythagorean theorem. Okay, that's what I'll do here. So let me use the Pythagorean theorem to find y, and I'll tell you why I'm doing y first in just a minute. So if I wanted to use Pythagorean theorem, we're going to get 4 squared. What did I just write there? I have no idea what the heck that is. Let's do it again. All right, so 4 squared plus 8 squared equals y squared. 16 plus 64 equals y squared. They did ask us to leave it in simplest radical form, so we're going to be looking at the square root of 80. And if we simplify the square root of 80, what is that? That's 4 and 20, and this is 4 and 5, so it's 4 root 5. So QR is 4 root 5, which is also SR, 4 root 5. Now if I come over here to the other side with PQ, I notice that this is an isosceles right triangle. Now that's not always going to happen with a kite. You're not always going to get an isosceles right triangle, but here we do. So an isosceles right triangle is a 45, 45, 90 triangle, which means that the hypotenuse, which is x, is equal to the side length, or the length of the leg, times the square root of 2. So that's pretty easy. We know that PQ and PS are both 4 root 2. Again, that's not always going to happen. You could probably just use Pythagorean theorem all the time, right? Not even need to notice these relationships. But I did want to point that out in case it does come up, even with the 30, 60, 90. There's a possibility that you could use those ratios. So use them if you could. Okay? All right, that's kites.